Let's move to the next question. In this question, we have to find the common difference of an AP, which is 1 upon P, 1 minus upon P, 1 minus 2P upon P. Let's work out the problem. Given AP is 1 upon P, 1 minus P upon P, 1 minus 2P upon P, so on. Let us rewrite the given series by separating the numerator to one of the terms in the numerator. Then we have the series 1 upon P, and then here we have 1 upon P minus P upon P. Here we separate the denominator to each of its terms, and then we have 1 upon P minus 2P upon P, like this, so on. It is 1 upon P minus 1, since P get cancelled, and then we have 1 upon P minus 2, so on. If A is the first term and D is the common difference, then the general form of an AP is A plus D, A plus 2 times D, A plus 3 times D, so on. If we compare the given series with the general form of an AP, we get the value of A is 1 upon P and common difference D is -1. Therefore, we can say that -1 is the common difference of this AP. Or we use another method. Let's move to the next method. Here we know that common difference is the difference between a term and its preceding term. Here we take a term that is second term, then the common difference is T2 minus T1. The T2 is 1 upon P minus 1 and T1 is minus 1 upon P. Then we have the value of D, which is 1 upon P minus 1 minus 1 upon P. Here 1 upon P and minus 1 upon P get cancelled. We get the value of common difference D is -1. Therefore, this relates to the option C. This completes our problem. Let's move to the next question. In this question, from a point P, which is at a distance of 13 centimeters from the center of circle of radius 5 centimeters, a pair of tangents PQ and PR are drawn to the circle, and we have to find the area of the quadrilateral PQOR. Let's work out the problem. Here, a pair of tangents from an external point P to the circle are drawn. Let the tangents touches the circle at Q and R respectively. Here we have given the distance of the point P from the center of the circle O is 13 centimeters. So we have OP is 13 centimeters and the radius of circle OQ equal to OR is 5 centimeters. We know that tangent of a circle at a particular point is perpendicular to radius of the circle at that point. Therefore, at point Q, tangent PQ is perpendicular to radius OQ. Similarly, at point R, tangent PR is perpendicular to radius OR. If we look at the figure, we form two right angle triangles. They are POQ and POR. We know the sides OR and OP, that is one side and hypotenuse, and we have to find the length of each tangent. By applying Pythagoras law, we can find the length of two tangents. Consider the triangle POQ. Here hypotenuse is OP. By applying Pythagoras law, hypotenuse square is equal to sum of the square of other two sides. Other two sides are OQ and PQ. Let's substitute the values. OP is 13 centimeters and OQ is 5 centimeters. By rearranging, we get PQ square is equal to 13 square minus 5 square. Here 13 square is 169 and 5 square is 25, and the difference is equal to 144. Therefore, PQ square is equal to 144. By applying square roots, we get the value of PQ is 12 centimeters. Since 144 is a perfect square, its square root is 12 centimeters. Therefore, length of the tangent PQ is 12 centimeters. Now we have to find area of quadrilateral PQOR. In this figure, we have to recall a property. When tangents are drawn from external point, the length of the tangents are equal. That is, the length of the tangent PQ is equal to length of the tangent PR. And here we can say that triangle POQ is similar to triangle POR. It is because triangle POQ is similar to triangle POR. It is because they has a side OP is common and angles are same, and also pair of tangents are same. By side angle side property, we can say that triangle POQ is similar to triangle POR. Therefore, these two becomes equal triangles, and we know that area of this quadrilateral is nothing but 2 times of area of triangle POQ. Now, area of a triangle is equal to half base into height. Then we have base is OQ and height is PQ. By substituting the values, we get OQ times PQ. Here OQ is 5 centimeters and height is 12 centimeters. Here numerator to denominator to cancelled out. We have 5 times 12 is 60. Therefore, area is 60 square centimeters. Option A corresponds to our answer. This completes our solution. Let's move to the next question. In this question, upper part of a vertical tree which is broken by the storm just touches the ground and it makes an angle 30 degrees with the ground. If the length of the broken part is 16 upon root 3 meters, then we have to find out the length of the remaining part of the tree. Let's work out the problem. Here we have a tree AB with top B. Let the tree be broken at point P by the storm, and the upper part touches the ground at B dash, and we are given the angle made by the broken tree is 60 degrees. And we are given the angle made by the broken part with the ground is 30 degrees. Then we have the angle PB-A is 30 degrees. Now we form a right angle triangle PB-A, and we are given the length of broken part, that is BP, which is equal to B-P, and it is 16 upon root 3 meters. And we have to find the length of the remaining tree, that is AP. And in this triangle PB-A, which trigonometric ratio gives the relationship between perpendicular and its hypotenuse? It is a sine. So we take sine of angle 30 degrees is the ratio of perpendicular to its hypotenuse. Let's substitute the values. Here sine 30 is 1 upon 2 and AP is unknown, and we know B-P, which is 16 upon root 3 meters. By transposing 16 upon root 3 meters to left hand side, we get AP is equal to half 16 upon root 3. And here 2 goes in 16 8 times. Therefore, the length of the remaining tree is 8 upon root 3 meters. It corresponds to option A. Therefore, option A is our answer. Let's move to the next question. In this question, we have to find the area of a square which is inscribed in a circle of radius 8 centimeters. Let's work out the problem. Here we have a circle with center O, and in this circle a square is inscribed, and we are given the radius of circle is 8 centimeters. Let it be R, and we have it is 8 centimeters. Let ABCD be the square. According to the question, we have to find out the area of this square ABCD. To find its area, we need to find its side. Let us denote the length of side is S centimeters, and then area of square is S square centimeter square. To find area, we need to find S. Here, sides of square are perpendicular. By using the given condition, that is radius of circle, we have to find out S. But how we can find? Here we have the diameter, which is 2r, which is equal to 16 centimeters. Here BD is the diameter and BD is also a diagonal of square. And OB is radius and OD is radius of circle. If you look at the figure, we have a right angle triangle HC, that is triangle BCD is a right angle triangle. To find the square, to find the value of S, we have to apply Pythagoras theorem. According to Pythagoras theorem, square of hypotenuse, which is BD square, is equal to sum of the square of other two sides. Let's substitute the values. BD is the diameter of circle, which is 2 times r whole square, and DC are length of side of square, which is S. So we have S square plus S square, and we have the value of 2r, which is 16 centimeters. S square plus S square is 2 times S square. 2S square is equal to 16 square. 16 square is 256. To find the value of S, we have to divide both sides with the coefficient of x square. Then 256 upon 2 is 128. What we assume S is the length of side. Here area of a square is S square, so we get the value of S square is 128. Since the units are given in centimeters, so we have centimeters square. Option B corresponds to our answer. Let's move to the next question. In this question, we have to solve the given equation for x. Let's work out the problem. Here the equation is x upon x minus 1 plus x minus 1 upon x, which is equal to 2.5. Here the RHS is in mixed fraction, so we convert it into improper fraction by adding the integral part to the fractional part. And on LHS, we take the LCM of the denominators, which is x and x minus 1, and it is equal to their product. Then on numerator, we have x times x plus x minus times x minus 1. On simplifying, we get x square x minus 1 whole square. In denominator, x times x is x square, x times negative 1 is negative x, and on RHS we have 2 is LCM, 2 times 2 is 4, and 4 plus 1 is 5, which is our numerator. Now we simplify numerator. Here x square plus x minus 1 whole square is x square minus 2x plus 1, and in denominator we have x square minus x, which is equal to 5 upon 2. To perform calculation easier, we use cross multiplication. Then we have 2 times x square is 2x square, and we have negative 2x plus 1, and on RHS we have 5 times x square minus x. Let us distribute these two inside the bracket. Now we have 2 times 2x square is 4x square, and 2 times negative 2x is negative 4x, and 2 times 1 is 2, and on RHS we have 5x square minus 5x. Now rearrange RHS and LHS. We have 5x square minus 5x, and on RHS we have 4x square minus 4x plus 2. Let us transpose 4x square to LHS. Then we have 5x square minus 4x square is x square. Similarly, negative 4x when transposed to RHS becomes plus 4x, and negative 5x plus 4x is negative x, and here plus 2 on transposing to LHS becomes -2, which is equal to 0. Let us factorize this. We have constant term is -2 and its factors are -1 times 2 or -2 times 1. Sum of -1 and 2 is 1, which is not equal to coefficient of x. So we ignore these factors. We have -2 and 1. Their sum is equal to -1. Here -1 is equal to coefficient of x. So we write x in terms of -2x plus x and -2 equal to 0. Let's take common x from these two terms. We have x times x minus 2 and here we have x minus 2. From these two terms we take x minus 2 common. Then we have x minus 2. Note that here 1 is the coefficient of x minus 2, x plus 1. To get the value of this algebraic expression to 0, each factor should be 0. Then we have either x minus 2 equal to 0 or x plus 1 equal to 0. From this we get the value of x, which is x equal to 2 or x equal to -1. This is the solution of the above quadratic equation. This completes our problem. Let's move to the next question. In this question we have to find the area of a right angle triangle given the radius of its circumcircle is 3 centimeters and the altitude drawn from hypotenuse is 2 centimeters. Let us draw a rough diagram to represent this figure. Here we have a right angle triangle ABC, and in this right angle triangle we have drawn an altitude CQ to the hypotenuse AB. Therefore, the length of the altitude is 2 centimeters. So we have CQ is equal to 2 centimeters. According to the question, we have to find the area of this triangle, that is area of triangle ABC. To find its area, we know height, but we have to know its base, because area of triangle is equal to half of product of base into height. So here we have to find out base of triangle ABC. To find the base, that is AB, we have given the radius of circumcircle. That means in a triangle ABC, a circle is drawn which touches 3 vertices of triangle ABC. Then it becomes a circumcircle. So when a circumcircle is drawn to right angle triangle, the diameter of circumcircle is the hypotenuse of right angle triangle, and the center of this circle exactly coincide with the midpoint of diameter, which is hypotenuse. So here we have radius, that is OB and OA, and it is given 3 centimeters. Therefore, base of triangle ABC, which is hypotenuse, is equal to 2 times radius, which is diameter. It is equal to 6 centimeters. And the area of right angle triangle is equal to half of base into height, that is AB into CQ. By substituting the values, we have half of 6 times 2, and here numerator 2 and denominator 2 cancelled out. So we have area is 6 square centimeters or 6 centimeters square. This completes our problem. Let's move to the next question. In this question, we have given a hemispherical ball of internal radius 9 centimeters and it is full of liquid, and this liquid is used to fill cylindrical shaped bottles, and the diameter of base circle is 3 centimeters and the height of each bottle is 4 centimeters, and we have to find the number of bottles required to empty the hemispherical ball. That means the number of bottles required to fill up the liquid which is in the hemispherical ball. So let's work out the problem. This is a hemispherical ball and internal radius is R, which is 9 centimeters. And it is given that the water in this ball is used to fill up the bottles which are in cylindrical shape. and given dimensions are the diameter of this base circle is 3 centimeters and the height of the cylinder, that is height of the bottle, is 4 centimeters. So using this we have to find out the number of bottles which are required to empty the hemispherical ball. Let the diameter of each bottle be 2r, where r is the radius and it is equal to 3 centimeters. Therefore we have the radius is 3/2 centimeters. Here we have to find the number of bottles. So we assume n be the number of bottles. To find the value of n, we must think what equation will give the value of n. Here, to empty the ball, volume of the liquid in the hemispherical ball is equal to the total amount of volume which is in the n bottles. So the volume of hemispherical ball is equal to n times the volume of each bottle, that is the volume of each cylindrical bottle. Volume of hemispherical ball is equal to half volume of a sphere, that is 2/3 pi r cube, where capital R is the radius of this ball. Then the volume of each cylinder is the area of base circle, which is pi r square into its height. Let's substitute these values. Here pi and pi on left hand side and right hand side get cancelled. Then we have 2/3 r cube. R is 9 centimeters. So here we have 9 times 9. Here n is unknown and we know the radius of base circle, and we know radius of base circle which is 3/2. Therefore 3/2 times 3/2, and height of each bottle is 4 centimeters. Let's simplify this. On left hand side 3 goes in one of the 9 3 times, and here the product of numerators 2 times 2 cancel the denominator 4. So we remain with 2 times 3, which is 6 times 81. 9 times 9 is 81, and n times 9. To find the value of n, we have to divide with 9 on both sides. Then we have 6 times 81 upon 9, which is equal to n, and 9 goes in 81 9 times. So we have the value of n, which is 6 times 9, which is equal to 54. Therefore 54 bottles are required to fill the liquid in this hemispherical ball. And this completes our solution. Let's move to the next question. In this question, we have to find the probability of getting a sum 9 when 2 dice are thrown. Let's work out the problem. When a single die is thrown, we may appear 1, 2, 3, 4, 5 or 6 on the upper face of the die. Therefore, total number of outcomes are 6 when a single die is thrown. Similarly, when 2 dice are thrown, we may either get 1, 2, 3, 4, 5 or 6 on upper face of each die. Here the total number of possible outcomes when 2 dice are thrown are tabulated. Here the first number in each ordered pair is the number appearing on the first die, and the second number in each ordered pair is the number appearing on the second die. Totally, when 2 dice are thrown, we have total number of possible outcomes are 6 times 6, which is 36. Now we take E is the event which denotes a sum of getting 9. Now from these combinations, we have to take two numbers whose sum is 9. So first we start with 1 and question ourselves, is there a number in between 1 and 6, including 1 and 6, whose sum is 9? No, there is no such a number. Then we move for 2 and we question, is there a number in between 1 and 6, including 1 and 6, whose sum with 2 gives us 9? There is no such a number. Let's move for 3 and we have a number 6 whose sum with 3 is 9. Therefore, there are two such ordered pairs which are 3, 6 and 6, 3 and their sum is 9. Next we move for 4 and there is a number 5 whose sum with 4 is 9. Therefore, 4, 5 and 5, 4 are our desired outcomes for the event E. So totally number of favorable outcomes to event E is 4, which is 3, 6 and 6, 3, 4, 5 and 5, 4. Now the required probability is probability of getting a sum of 9 when 2 dice are thrown is the ratio of number of favorable outcomes to event E, that is n of E, to the total number of outcomes, that is n of S. And we have their values 4 upon 36. Here 4 is the common factor. So 4 goes in 36 9 times. We have the probability 1 upon 9. Option B corresponds to our answer. Let's move to the next question. In this question, we have to find out the volume of the largest right circular cone that can be cut off from a cube whose edge is 4.2 centimeters. Let's work out the problem. Here we are given edge of a cube. Let it be A and it is 4.2 centimeters. And we are asked to find the largest volume of the right circular cone which can be cut off from the given cube. To get the largest volume, the dimensions of the right circular cone, which is height and diameter of base circle, should be equal, and it is equal to edge of cone. Then we have height of a cone, which is 4.2 centimeters, and diameter of base circle, which is equal to 4.2 centimeters. Then we have the radius of the base circle is 2.1 centimeters. The volume of a cone is 1/3 of pi r square h. Let's substitute the values. Here we have pi 22 upon 7 and radius is 2.1. Then we have 2.1 times 2.1 and height of cone is 4.2 centimeters. 7 times 3 is 21 and on numerator we have 22. Here in numerator and denominator 21 goes in 2.1 times. By multiplying 22, 2.1, 4.2 and 0.1, we get the volume approximately 19.4 centimeter cube, and it is equal to our option D. Let's move to the next question. In this question, which term of the AP 45, 41, 37, 33 is the first negative term? According to the problem, we have to find out the first negative term of this AP. Here we have given AP is 45, 41, 37, 33, so on. Here the AP is in decreasing order, so we have to find the number of the first negative term. Let's work out the problem. First term of the AP is small a, which is 45, and we know that common difference is the difference between the term and its preceding term. Here we take second term, which implies 41 minus 45, and it is equal to -4. Therefore, we have the value of D is -4 and A is 45. Let us assume nth term be the first negative term. That means the value of nth term is less than 0 since it is negative. According to the general term of an AP, if A is the first term and D is the common difference, then the nth term is A plus n minus 1 times D. According to this situation, it is less than 0. Let's substitute the values. We have 45 plus n minus 1 times negative 4, and it is less than 0. 45 plus of minus 4 is minus 4, and then we have 4 multiplied with n minus 1. It is less than 0. Let us transpose negative 4 times n minus 1 to this side. That is the right side of this inequality sign. Then we have 45 is less than 4 times n minus 1. Let us rearrange this. That means 4 times n minus 1 is greater than 45 by rearranging the above equation. Now let us distribute 4 inside the bracket. We have 4 times n minus 4 is greater than 45. Let us transpose negative 4 to right hand side. Then we have 4n greater than 45 plus 4 is 49. On dividing both sides with n, we get n is greater than 49 upon 4. 49 upon 4 is 12.5. Here n is an integer. N should be 13, 14, 15, 16. According to the problem, we have to find the first negative term. Here the first negative term is the first value of n. So 13th term is the first negative term. And this completes our solution. Let's move to the next question. In this question, a circle touches all the 4 sides of a quadrilateral ABCD, and given the length of the sides AB, BC, CD as 6 cm, 7 cm, 4 cm, and we have to find out the length of the remaining side, which is AD. Let's work out the problem. Here ABCD is a quadrilateral, and we are given the length of the side AB is 6 cm and BC is 7 cm and AC is 4 cm, and we have to find AD. If you look at the figure, the circle touches the 4 sides of quadrilateral, and then the sides AB, BC, CD and AD becomes tangent to this circle. So we use this property to get the unknown side. Here we have a circle, and to this circle a pair of tangents are drawn from the external point P, and we know that the length of the tangents drawn from external point to a circle are equal. So the length of the tangent PR is equal to PQ. Here we use this property to get the unknown side AD. In the figure we have 4 points A, B, C, D. Let the side touches the circle at P, Q, R, S, and then A becomes the external point, and from this point we have drawn 2 tangents which touches the circle at P and S respectively. From this property we have the length of the tangents AP is equal to AS. Similarly, the length of the tangents from B, BQ, BP are equal. Therefore we have BP equal to BQ, and the length of the tangents from C, CR and CQ are equal, and also length of the tangent from D, DR, DS are equal. Therefore we have got 4 conditions, and we use these conditions to get the remaining side. Now consider the sum of any 2 opposite sides. It may be AB, CD or AD, BC. So we consider sum of AB and CD. And we can write AB is equal to sum of AP, PB. And similarly, we can write CD sum of CR and RD. And here we have AP is equal to AS. So we substitute, and BP is equal to BQ. Similarly, CR is equal to CQ, and RD, which is DR, is equal to DS. If we consider here the sum of AS and DS, sum of AS and ds is AD. So here we have AD, and then we have sum of BQ and CQ. Sum of BQ and CQ, it is equal to side BC. That means when a circle touches four sides of quadrilateral, the sum of any two opposite sides are equal. Here the sum of AB CD is equal to sum of AD and BC. So by using this condition, we can find the remaining side AD. In the question we have given the length of sides. AB is 6 centimeters and CD is 4 centimeters, and here we have to find AD, and BC is 7 centimeters. So we have 10 is equal to AD plus 7. By subtracting 7 from both sides, we get the value of AD is equal to 3 centimeters. So remember here, when a circle touches four sides of a quadrilateral, the sum of opposite sides of quadrilateral are equal to sum of remaining opposite sides of quadrilateral. Let's move to the next question. In this question, a bag contains 5 red balls, 8 white balls, 4 green balls, 7 black balls. A ball is drawn at random from the bag, and we have to find out the probability that the drawn ball is black color, and in the next we have to find the probability that the ball drawn is not green. Let's work out the problem. According to the question, here we have 5 red balls, 8 white balls and 7 black balls, 4 green balls in a bag. And here an experiment is performed, which is a ball is drawn from the bag. And here we have the ball drawn may be either red ball or white ball or black ball or green ball. Totally, number of outcomes of this experiment are sum of these balls. Let the total number of outcomes be n of s, which is equal to the sum of balls, that is 5 red balls, 8 white balls, 7 black balls and 4 green balls. Their sum is equal to 24. And here we are supposed to find the probability that the drawn ball is black color. So if we take E is the event that the ball is black, then we can find the probability. So the total number of favorable cases to our event E is 7, since we have 7 black balls in the box. So the number of favorable outcomes to event E is 7. Now we can find the probability of event E, that is the probability that the drawn ball is black color is equal to the ratio of number of possible probability that the drawn ball is black is equal to the ratio of number of favorable outcomes to E to the total number of outcomes, which is n of E upon n of S. And here we have favorable cases 7 and total outcomes are 24. So the probability that the drawn ball is black color is 7 upon 24. Let's move to the next question. That is the probability that the ball drawn is not green. Here we have to find out the probability that the drawn ball is not green. We can find this solution in two ways. That is, the drawn ball may be black, or it may be red, or it may be white. So here we take F is the event and it denotes that the drawn ball is not green. And then number of favorable outcomes to event F is 5 red balls or 8 white balls or 7 black balls. And the sum is 20. Let it be n of F, which is 20. According to the problem, the probability of event P, according to the problem, the probability that the drawn ball is not green, that is P of S, is the ratio of total number of favorable outcomes to F, which is n of S, to the total number of outcomes, that is n of S. And here we have the values 20 upon 24. If you look at the numerator and denominator, 4 is the common factor. So 4 goes in 20. 5 times and 4 goes in 24 6 times. Therefore, the required probability is 5 upon 6. And this completes our solution. Let's move to the next question. In this question, we have to find out the probability that there are 53 Wednesdays in a leap year. So let's work out the problem. We know that in a leap year, there are 366 days. How many weeks it consists of? In a week, we have 7 days. So when 366 is divided with 7, the quotient gives number of weeks and the remainder gives number of days. So here we have remainder 2 and quotient 52. So there are 52 weeks and there are 2 extra days. So here our aim is to find there are 53 Wednesdays in a leap year. We have 52 weeks. So there are 52 Wednesdays. Since in a leap there is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. So here we have totally 52 Wednesdays. Then what about the 2 extra days? 2 extra days may be either Monday, Tuesday or Tuesday, Wednesday or Wednesday, Thursday or Thursday, Friday or Friday, Saturday or Saturday, Sunday or Sunday, Monday. So totally we have 7 possible outcomes that there may be the extra 2 days. So totally we have 7 number of possible outcomes. Here we have to find there are 53 Wednesdays. So we take E is the event which denotes that a leap year has 53 Wednesdays. Then the number of favorable outcomes to this event are n of E, and here we have to get 53 Wednesdays. From these extra 2 days, there should be Tuesday or Wednesday or Thursday. Then we get 53 Wednesday. So totally number of favorable outcomes to this event E is 2. And our aim is to find the probability that there are 53 Wednesdays. So it is the ratio of total number of favorable outcomes to event E to the total number of outcomes. That is n of E upon n of S. And we have their values which is 2 upon 7. So in a leap year, the probability that there are 53 Wednesdays is 2 upon 7.